All right, so I'm just going to jump right into it. The intention today is to get familiar with a few different concepts, and they might sound a little ambitious at first, but my hope is that by the end of this, you'll have a pretty good grip on what we're talking about, and you could go tell one of your friends about it. So the first is, what the heck is the fungi to bacteria ratio, and why do we care about it? Why do our plants care about it? The second thing we're going to dive into is why soils tend to be deficient in fungi. The third is why many composts and amendments tend to have an abundance of bacteria, but are also deficient in fungi. And then lastly, we'll explore a couple ways that you can improve the fungal biomass of compost at home that you put into your garden. So we can't talk about fungi to bacteria ratio without rehashing a concept that you've probably seen at some point in your career through schooling or a book somewhere. And that is the concept of ecological succession. So this idea that we have a barren landscape or a disturbed landscape that gets colonized by a certain type of plant species. Typically, these are little scrubby plants, your bryophytes, mosses, lichens, and that sets the stage for more complex life to start thriving on that landscape. So these are two kind of depictions of that process. And this is important because we can visualize this above ground really clearly, as these diagrams show. But what a lot of people don't realize is that there's a whole ecosystem below ground that is also transitioning with each stage of succession. And so it's through Dr. Elaine Ingham's work and many of her colleagues over the last few decades that we're starting to understand what the below ground ecosystem looks like in each of these stages of succession. And what they've generally found is that early succession landscapes are generally bacteria dominant. They have a lot of bacteria and very little fungi. Whereas your more mature, your late successional plants, like your conifer trees, prefer having partnerships with lots of fungi and relatively little bacteria below ground. And this mostly boils down to the types of nutrients that are becoming available to the plants. So when there's a lot of bacteria in the root zone, the types of nutrients that become available to the plants are very different than when we have more fungi to bacteria. So this is depicted in this particular diagram with the more nitrate being underneath the bacteria dominant side of this picture, where there's more ammonium being available when there's more fungi in the system. So put another way, the type of nitrogen that a plant likes to take up will vary depending on the successional group it belongs to. Most of our crops are somewhere in a mid-successional range. We do have early successional crops, like the Brassica family is considered an early successional crop, and they do pretty well in our relatively disturbed soil system that have a lot of bacteria and very little fungi, but we tend to struggle with crops that require more fungi than is currently in the soil. So when I look at a lot of soil samples for various clients, they tend to fall into this ratio of more bacteria than fungi. And the way that I've kind of summarized this before is we're essentially trying to grow mid to late successional plants on early successional landscapes. So it's really up to us to kind of inform the root zone in a way that we want to be growing later successional plants. And a few ways to do that is to mostly stop disturbance and protecting soil. So the common disturbances that Mary already kind of recapped for us are tilling. Like anything that's going to disrupt the soil is kind of like that fire that was depicted in that vegetative landscape. It's kicking succession back. That ecological disturbance of fire is moving the vegetation back to an earlier succession stage, just like tilling is an ecological disturbance to the below ground ecosystem, and it's moving the below ground ecosystem back in an earlier succession stage, which means it has that impact on what can grow in that space. So tilling, compaction, any kind of exposed ground is also a form of disturbance. So even though it doesn't seem as physically disruptive as something like tilling does, leaving ground exposed exposes it to wind and water erosion. And usually what happens there is that you end up with compaction issues because of the actual impact that water is making as raindrops hit that exposed soil. And then you also end up with crusts a lot. I'm sure everyone's experienced this. When you don't mulch your gardens, you can end up with a crust usually on top. As the water evaporates from that soil system, it's drawing up the smaller particles of that soil, and it's bringing them to the top of that profile, and then it kind of caps off the soil. So that's just something to consider when we're talking about common disturbances. So just kind of reiterating something that I said earlier is that generally on a global scale, we're disturbing our soils, and we're essentially causing that soil microbiome to exist in an early succession stage, all while trying to plant and grow mid to late successional plants. So once you kind of know this, you can start doing things differently. You can't really unsee it once you're like, okay, well, every time I disturb the soil, I'm moving that landscape back in succession. And we're often constantly creating disruption, right? So it's not that we aren't going to disrupt our landscapes, that we would just set it and leave it. It's more that we take measures to inoculate and introduce fungi, for example, into that soil system, and we're protecting the soil system so that we're preserving that fungi to bacteria ratio, keep it moving in the direction that we want it to for the sake of our plants. All right, so we're going to move on to compost. Compost is a funny word. So is anyone brave enough? I hope to get a few answers. What, in your own words, how would you define compost? Takers? Organic matter. Organic matter? Decayed organic matter? I like that. Living soil? Anything else? Yeah.
Things I've intentionally made rot.
Things I've intentionally made rot, like that. Okay. I mean, I knew I'd get good answers being in a room full of gardeners. So I just like to point out like how loosely we tend to use the word compost, because here's a picture of something composting, right? You can still kind of see the types of food scraps and things that were put in there. But then we also tend to call all this stuff on the countertop that's yet to make it into the compost bin compost. And then the actual finished product we also call compost. So I like to use this sentence of using the word compost in all its ill-defined meaning. We could say, I took my compost, the food scraps, out to the compost, the composting pile, to make compost, the soil amendment, right? And that's like calling flour and eggs, batter, and the resulting baked good all cake. I put cake together to make cake, and then I baked it into a cake. And that's very nonsensical, right? So I'm trying my best. I'm not perfect at this, but I try to use the words that I really mean when it comes to compost, and that is calling the image in the top left food scraps. I call the actively composting pile the compost. Compost for me is a verb, it's an action, it's a process. And then the finished product, I like to call that an amendment, soil amendment. And when you start thinking about it that way, you start getting a little bit pickier, more intentional, to use Mary's term, of what kind of amendment are you really creating there? How are you composting? What food scraps are you putting into the compost? All right, so now we're going to just really dive into the idea of creating a fungal-rich compost. When I look at compost from industrial composting facilities, what I tend to see is a lot of bacteria and very little else. And we want to see not only bacteria, because we've just been talking about how having bacterial dominant soils is kind of a problem, and we don't need to be adding more bacteria to bacterial dominant soils, right? We want to be adding fungi, and we want to be adding protozoa as well as nematodes. And so protozoa and nematodes are kind of getting into the bigger picture of the whole soil food web. So just deviating a little bit from the fungi to bacteria ratio focus, and considering the whole food web, we want these predators that are feeding on bacteria to actually keep those populations in check, while we're also introducing fungal biomass to be tailoring in that ratio relative to the successional stage of the plants that we're growing. So when it comes to composting in our backyards, the biggest factor is going to be what you're putting into that compost pile. And this is where you can really differentiate yourself from these industrial composters, which the way I view a lot of industrial composting is that they're serving a purpose in diverting waste from the waste stream. So you're taking organic matter, usually in this context, you're shredding it, and then you're heating it just for the sake of making sure that there's no human pathogens in it. So they're regulated in a sense to hold up these certain temperatures, not for the sake of generating a great soil amendment, but just so they're not creating something dangerous for us to handle in our gardens. And I would call that, in our industry, we would call that ground up organic matter. It's not compost. It's not a soil amendment. It's a lot of organic matter, which can be useful, but it's not a very powerful inoculant when it comes to our gardens. So at home, what you can do, or even if you have like a large area that you need to cover, you can get this industrial ground up organic matter, GOM, as we call it, and you can actually inoculate that with some very intentionally composted materials that are very biologically active. And you're basically applying those microbes onto that ground up organic matter to inoculate it and introduce that into your garden. When you're feeding a compost pile, instead of just feeding it whatever food scraps are coming out of your kitchen, you can intentionally start introducing some fungal foods. So there's nothing inherently wrong with doing, backyard composting with food scraps. It's just that we also want to keep in mind, are we getting a certain kind of food in there that the fungi are really going to like? Because unintentional backyard composting does tend to be similar to this bacteria-rich compost that we see coming out of industrial facilities. And that's because a lot of the inputs there are like our green materials, so grass clippings, a lot of the sugary parts of the foods that we're tossing out, things that are rich in nitrogen tend to be green. So that's why we call that like green materials, but that it could also include manures. Those are the only ones coming to mind right now. But bacteria really digest simple foods really, really well, where fungi prefer more complex foods. So as opposed to a simple sugar, they like complex sugars that you'd find in something more like a whole food, or any kind of like seed or oils, something that's more complex than a simple carbohydrate. So I want to I'm going to skip around just a little bit. So if you have a compost at home, raise your hand if you are composting at home. Yay. Okay. How many of you are using worms? Awesome. How many of you would you say are hot composting? Thank you. Cool. Okay. And how many would you say static composting? Okay. Any other ones that I didn't mention that you might be doing? Lasagna composting. Do you kind of set it and leave it? Do you turn it?
Layer garden with different things.
Okay, like right in the garden. Okay, got it. Cool. Okay, so in a lot of these scenarios, you can just lightly feed any one of those composting methods with fungal foods. And I've listed some here as examples. Oat flour is one that I've found really has an impact on the particular fungi that I assume everyone here would have a little bit of just because we're in the same area. Soybean meal, I'm starting to experiment with. Feather meal, barley, humic acids. Fish hydrolysate is a commonly named fungal food, but don't get it confused with fish emulsion. Fish emulsion has had the fish oil removed, and so that'll actually really increase your bacteria biomass and not your fungal biomass. So we have to be a little bit careful with these things. That's why I really emphasize the light feeding of it. But as an example, a lot of vermicompost that I've looked at is pretty hit and miss on how fungal it is. They tend to be pretty low in fungal biomass. But I've seen some recently that have really great fungal biomass. And so I went to the client and I said, what are you doing? What are you doing differently to try to get to the bottom of it? And they're lightly feeding things like oat flour, oatmeal. And it's really simple to just start adding a little bit of that fungal food. You don't need to overdo it. They're mostly just feeding their kitchen scraps to these worms, but every now and then they'll just intentionally incorporate a little bit of fungal food, and that's really increase their fungi to bacteria ratio. Yeah.
Growing oats. Was that
If you're growing oats, so the way that I think of, I guess, the composting versus doing it kind of in situ, like you're talking about, is like you can do it either way, but one's a little bit more of a controlled environment. I would think of compost as a more controlled environment, so you can tailor the kinds of organisms that you're growing. But you can also lightly feed the bees directly to the soil too. I mean, that's why people sell kelp meal as a fertilizer, for example. Kelp, by the way, would feed both fungi and bacteria. But you could lightly feed in the garden with these things. Yeah, does that answer your question?
So the oats will fall down, you will eventually.
Yeah, exactly. As long as you're not harvesting all of it and taking it, hauling it away, then yeah.
Where did you add the mushroom block?
We'll get to that for sure. Yeah. Thank you for bringing that up. Because I'll definitely talk about the mushroom blocks since we have access to them.
What effect does coffee grinds have and chicken manure?
So both coffee grounds, a lot of people would consider high nitrogen, but if they're spent coffee grounds, like you've actually used the coffee, I would consider them to not be so high nitrogen, but more green material. So still feeding like your long-term stores of bacterial food in your compost. That's the difference between high nitrogen and green materials. These are kind of misnomers. They're poor. It's poor language to differentiate the two, but a high N would be your manure, as long as it's not been sitting out and rained on a lot, because every time there's an event like that, it is leaching out some nitrogen, and so it might become less and less high nitrogen. Yeah.
What about adding cheap dog food? Let's look at that. Adding cheap dog food to a compost. Is that adding in with some fungi?
Oh, sure, yeah. Okay, so the question was, what about adding in cheap dog food to the compost? So I really can't suggest doing that without looking at samples under the microscope. That's the thing with composting, is like you can't tell the difference between one amendment and the other just by looking at it with the naked eye. It's not until you get under the microscope to really tell what effect a certain input, a certain food had on it. But of course, not everyone has a microscope, and not everyone's going to be able to differentiate that. So I only feel comfortable sharing these particular food sources because I know that they'll have that impact. The things to be looking for within other foods would be, is it high in protein? That might be where this dog food recommendation came from. Is it, does it have, a starchy component, something that's kind of complex? So that very well could be a solution, but I wouldn't know for certain. Yeah. Yes.
Can you define what those three kinds of compost are? I'm familiar with compost, but the vermicompost.
Yeah, so what I mean by vermicompost is worm composting, so using like a worm bin of some kind. And then static compost is usually a larger heap of material that you're composting long term. So the way that I've seen this done really well is when you have a lot of material. I mean, I'm talking a mound like taller than I am, and maybe 10 to 20 feet wide, and you just bury your food waste in there. You can even compost carcasses, so like if you were living on a ranch or something, your livestock, anytime you could bury that, and that would prevent any smells from escaping for the wildlife to be too, you wouldn't want them too interested in it. And you set it and leave it for a long time to do its thing, and then you come back and check on it every now and then. And then hot composting, it sounds like you were familiar with that one, but in case anyone else isn't, that hot composting, you're intentionally trying to meet certain temperature requirements in order to kill off things like weed seeds and pathogens, whether that's a plant pathogen or a human pathogen, and that's necessary when you're using things like manure. So I would really recommend using temperature as a way to create a safe amendment, but it's not always necessary. So some other ways that you can create fungal-rich compost is if you're wanting to start one from scratch. The best method that I've found, again, through looking at samples, is this method called the Johnson-Su bioreactor. And that's named after a husband and wife duo out of the University of New Mexico. They developed this, it's called a bioreactor, but it's really just a big cylinder, and it's a very passive system. It has like chimneys built into it, and it intentionally is filled with very like lignin-rich materials, so leaves and wood chips. And this is where you can start incorporating things like the mushroom blocks into that design to really just raise a bunch of fungi. So these are usually done within about a year. It really depends what you fill it with. Leaves will be done sooner. The more wood chips you have in there, the closer to a year or so it will take to break down. And this is the method that y'all are going to be doing a workshop on Saturday with Joseph. So, so that, yeah, you wouldn't want to miss that. This is a really easy, like kind of low maintenance. You just build it in one day, and then you set it and leave it and make sure that it has enough moisture throughout the year, and then it's ready for you to use the next year. And then hot composting is really about ratios. So, if you're intentionally trying to get up to temperature and turn your compost, you want to be doing that with a particular, like you want to be knowing what you're putting into your compost before those heat cycles get up, and then you don't want to be adding anything into it like while it's actively composting. So the way that I do this is I tend to save a lot of my inputs and dry them down until I'm ready to build that compost pile. and then I re-wet them. So like grass clippings, for instance, you don't want to leave those, getting moldy on a tarp somewhere because you're actually losing a lot of nitrogen. So you can dry them out in the sun, just like rake them out, make a really thin layer, store them in a couple totes until the day that you're ready to mix them with some wood chips and manure and call that your hot compost pile. So you can really see that this one emphasizes the woody materials. Over half of this pile, it ought to be woody materials, and that can incorporate cardboard. It could be leaves, wood chips. Those are going to be like your bulk materials that kind of make up that 60% woody component. And then again with the vermicompost, you could actually use either one of these, the Johnson-Su bioreactor amendment that is a result of that, or the hot compost amendment that comes out of that. You can use that as the substrate for the bedding for the worms, in addition to lightly feeding fungal foods to that worm bin. So I've seen people do really well with kind of saving a bit of their worms bedding, and that's the source of inoculation for the next worm bin. Yeah.
So you talked about how you would set aside your woody materials and let them dry so that they don't get moldy, but isn't mold fungus?
Good question. Yes. So mold is fungus, but mold is not the fungus that we want necessarily growing in our compost bin. And so there's a couple of things I want to say on that. And I hope the question came across in my answer, but the question was, I said to dry down materials on a tarp and so that they wouldn't get moldy, but what's the problem with them getting moldy if mold is fungi? So it is the greens and the high nitrogen are what's most important to dry down. The woody materials can kind of remain moist because those are strictly fungal foods. Like there's really not that much bacteria growing on there. In fact, I like to age wood chips before putting them into a compost bin because there's a lot of saprophytic fungi that are going to just start breaking down that material. And that's the beneficial fungi that we actually want in our compost and in our soils. The kinds of fungi that we find molds, mildews, and root rot in are a family of fungi called oomycetes. And they look really different on the microscope, actually. So we can really see when there's a lot of that activity, and they tend to thrive in low oxygen conditions. And our root zone prefers aerobic conditions. So we really want to be raising aerobic microbes in our composting systems so that we're inoculating the root zone with aerobic organisms instead of the molds, the mildews, and the rots. Yeah, really good question. Mm-hmm.
In my compost pile, I don't ever put any woody material in because it just takes so long for it to break down.
Yeah, it does take long.
Right, I just assume, put it in the grass.
Mm-hmm.
Things that break down fast, but I can use it right away.
Yeah. So the hot composting does take a lot, is a lot quicker at breaking down the woody materials than something like a Johnson-Su bioreactor that's more static. So to kind of give you an idea, if you're doing hot composting really intentionally, like you're getting up to those temps and you're turning it like maybe 3 times in the first couple weeks, a lot of the wood chips, first of all, you would hope to get smaller. It's okay to have pretty small wood chips. I wouldn't do anything like sawdust, but having fine wood chips will help you get to a finer material quicker. And I can get a really great fungal dominant amendment out of an intentionally managed hot compost pile in about 30 to 45 days. That's not that long. So it can be done, but you have to be resourceful with what types of woody materials you're putting in there. I would encourage you to do leaves if you can. So especially around the fall time, picking up all those leaves people are putting on their curbs. Grab some of those, put those and incorporate those into your compost. I think that's a really good place to start if you're feeling bothered by how long sometimes those wood chips live.
Andie, somebody on the Zoom asked about slime mold.
Mm.
That is that the same as like
Yeah.
a green mold or anaerobic?
Yeah, slime molds can be pretty different. My understanding is that some slime molds are actually made up of amoeba that can make spores. I learned that recently. But slime molds, I think, can be pretty different. I don't tend to find slime molds in actively composting material. I do find slime molds growing on my woody materials that are kind of sitting ready, like the mulch pile that's about to go into the compost. I'll see them in there, but then once I'm starting to compost, they don't like the heat that's generated in the hot composting. But I'm not sure about Johnson stew. Joseph, have you ever seen slime molds in a Johnson stew?
I have after like a period of months.
Yeah.
They usually go away. Like the initial period whenever you're filling it up, that goes through that thermal phase and it's not gonna attract the slime mold there. But after it's cooled down and its presence there, then I use the mushroom blocks as well. And I still think it's slime from the chimney cylinders.
Cool. Yeah. Yes, in fact.
You mentioned a good source of the wooden material, bags of leaves. Is there an easy or accessible source of the material?
For green material? Yeah, so the question was, is there an easy resource to procure green materials? So green materials, the easiest that come to mind are coffee grounds. So spent coffee grounds, you can call around to a lot of these local coffee shops. They tend to, especially like a roaster location, they tend to make a lot of cold brew, and they have like a cold brew day, and then they'll just like have a bunch of grounds that they put out on the curb, and you can come pick them up. Coffee grounds are a good source of green material. My favorite are, because I have a lawn that I don't love, but I have to mow it, and those are my greens. Any kind of weeding, those are greens. So any kind of trimming that you're doing in your garden as you're pruning, like maybe collect those. You can let things fall and go like feed back into the garden, or you can collect them and compost them and then return them to the garden in another way. The difference is, one is really helping you generate an inoculant, and so that might be really useful in certain contexts, whereas another is regenerating the soil right there in place. Mm-hmm.
Oh, I just had one more suggestion, since we mentioned like wood chip, and then the suggestion was sweet leaves. If you have like a push mower or a pot mower, if you got like a big leaf pile, you can break up the leaves pretty quickly with a lawnmower before you add it to your pile, and that'll help with the decomposition process, so it'll be ready soon. So you can just speed up that process. But if you want to try that style of static Johnson to composter, compost biomatter, you can again try that method and let it all speed up the breaking down process.
Yeah.
I had another question. So I do my compost and then I determine, okay, compost is ready to start using. It's like compost and all that stuff. Does it have a shelf life? Do I have to use it within a certain couple of months, a couple of weeks? Does it get to a point where the compost is good anymore?
Yeah, so there is a sweet spot, and this is something that does change from one compost pile to the next. Like if you're able to look at it on the microscope, you can really see that like the microbiome is changing over time. So what I found is that if compost is still warm, that's too soon, right? You never want to put warm compost onto your plants, because odds are it's likely still very bacterial dominant. And in fact, it could be slightly anaerobic and generating compounds that could actually be really harmful to your plants, like alcohols and things that would actually harm the plants. Now, how long is the shelf life? Generally speaking, if you're keeping it protected, your compost pile that you haven't used yet, and you're keeping it relatively moist, you want to be able to, when compost is done with like the heat cycles, you want to be able to go over to it and squeeze it and it feel kind of spongy. And maybe one drop comes out when you squeeze it really hard. You don't want it too moist, but that will allow the fungi to actually repopulate. So you do want this kind of rest period after especially in hot composting, for the beneficial organisms, especially fungi, to repopulate. And that you can let that continue going on as long as you want. So let's say you're not ready to use it for 10 months, your compost, as long as it stayed moist, should still be a pretty powerful inoculant. I would say use it within a year and a half would be like my general rule of thumb for most any compost. Yeah. Okay, so kind of on that note, some considerations when it comes to lightly feeding these composts is you want to make sure that anything that you are adding doesn't have like an antimicrobial property to it. So if you're purchasing like a soybean meal, for example, or a kelp meal, there might be a preservative in that material. And so always read the directions. Like if there's a way that you're supposed to neutralize the product, usually that means you wet it for a while and you do it in a certain ratio with a certain amount of water to kind of disrupt that antimicrobial effect. And then you can introduce it to your compost pile. So just wanted to make you all aware of that possibility. And then the diversity of your inputs. So just because you found one humic acid brand that you like using, which you can also generate your own humic acid at home with an existing compost pile. So humic acid is just a very complex structure that we find in humus, whether that's in our compost or in the soil. And when you run warm water over your compost and the leachate that comes out of it, that generally has a lot of humic acid in it. And you can use that to feed you can use that to feed your garden directly, or you can use that to feed maybe a younger and more immature kind of compost pile that you have going. And that's going to introduce some more complex compounds for the fungi to enjoy. But in terms of diversity, don't just stop at one fungal food. You can choose 5 fungal foods. You can choose 3 different brands of one type of fungal food. And those will generally select for a diversity of fungal species in that compost.
When people talk about creating like a wheat oil tea, would that be kind of what they're pulling out of the wheat?
Yeah, that's my understanding. Do you know how long it's sitting or how people do that?
I don't.
Yeah.
I just like heard people talk about, taking their moldy leaves and making it tea.
Mm-hmm. Yeah, I wouldn't ferment anything for this, but I would just do a leachate when it comes to like leaf molds or any other kind of organic material that you want to collect the liquid from. So getting back to those mushroom blocks, something to keep in mind is that the substrate that is growing those mushrooms, those culinary mushrooms, is made up of some kind of seed hull usually, and that is great fungal food, but it also has quite a bit of nitrogen in it, which does heat up a pile. And heat is coming from generally it's coming from the reproduction of bacteria. So when we have really high temperatures, that is a result of bacterial reproduction. So that means we have very bacterial dominant compost at that moment in time. And we just want to be careful with how much heat we're generating. So we don't need to get crazy with it. A lot of times people brag about like how hot my compost is and for how long it's that hot. The heat is a tool. The heat is a tool to kill the weeds, and it's a tool to kill the pathogens that might have been in your feedstocks, the inputs that you put into that compost. But other than that, like we want to kind of minimize heat. We just want to hit the like 131 Fahrenheit for up to 72 hours, turn it and do that about 3 times. We don't want heat being generated off the charts like 170 for days on end. That's too much heat. And I find that if you get overzealous with the amount of mushroom blocks you put into a compost, sometimes it can generate more heat than is desirable. And it takes the pile longer to mature once that temps come back down to ambient. Does that make sense? Yeah. So I've kind of come up with this ratio, and it's subject to change based on experience, but ideally I'm putting in about 30% or less of my total volume is made up of these mushroom blocks. And then the rest period is something that we talked about, is that allowing that pile to repopulate. So now that we kind of understand what heat is doing and using heat as a tool, once the temps come back down to ambient, it's good to let that pile rest for a couple weeks without turning it. As long as nothing's smelling, you know, if you smell something, that means something's anaerobic and you would want to turn it. But as long as nothing's smelly or too waterlogged, you can just kind of set it and leave it, keep it a little bit moist, and the fungi are going to be repopulating during that time. So on that kind of aggressive timeline of the 30 to 45 days of a hot, like intentionally hot composting to get a finished amendment, about the first 2 weeks of that are the heat cycles. And then the rest of that period is the rest period. And it's the repopulating of that compost. Cool. So that's mostly what I have for you today. And any more questions? Yes.
You said like the 60% being lead material.
Mm-hmm.
Is that including like substrate? Like if you added mushroom blocks, is that like it's the substrate is there and material too?
Yeah, good question. So the question was the 60% woody materials, would you include the mushroom substrate in that? And that one's a little tricky. So there's always these feedstocks that are going into compost that you're like, oh, that's kind of behaving like a green material, but it's also kind of behaving like a woody material. And the best way to do that is to maybe think of it as a percentage. So in the case of the mushroom substrate, I'd say like the amount that I put into a pile, I'm going to treat maybe 75% of that as a woody material, but I'm going to count at least a bucket of the amount that I took. Like if I have 4 buckets that I'm putting in, I'd say 3 buckets are going towards my woody materials and 1 bucket is going towards my green materials to kind of differentiate the effect that it's going to have on the pile. Yeah.
Spent brewery grains, do you think those would be good for fungal combinations?
Spent what grains?
Brewery grains?
Oh,
like,
brewery grains.
yeah, barley.
Yeah. So the beer mash, brewery grain, spent grain. I like to use this as a high nitrogen material. It definitely drives heat. I use it sparingly, so only up to 10% of my pile is beer grain. It's a good alternative if you don't have access to manure, or if you don't want to deal with manure, to be honest. I have close neighbors and I was a little worried about handling like a lot of manure, like worried that it's, you know, they not want me composting next to them anymore. So I just went ahead and have been using spent beer mash. It's really wet because like, you know, because they're brewing it. And so you got to use it quick. So it's always the last ingredient that I pick up because it's just so hard to dry down. Yeah. Yes.
I don't know if I do this right or not. I threw in some sourdough starter that was old.
Oh.
Kombucha, mother,
Uh-huh.
I threw those and just like, no.
Yeah.
Maybe that's okay. I don't know. Is
Yeah.
that thing, carbon or what?
Yeah. So kombucha starter, sourdough starter, can we throw those in the compost? And if so, what's it adding? Usually with things like that, the amount is like pretty small, right? So I think it's fine to add that in. I would consider most of that stuff to be a green material. Like most food waste coming out of our kitchens, are going to be greens. So it's not that they're the party food, as Dr. Elaine calls high nitrogen materials that really generate a lot of bacterial growth, but they're the kinds of foods that will sustain bacteria in that compost long term. That's what green materials are. So I view those items as potentially a green material, but I wouldn't know for sure. Yeah. You have a question?
Yes, if you make aerobic compost tea with molasses and worm compost, is that bacterial?
Yeah, so molasses is like exclusively a bacterial food. So if you use, so there are some benefits you can get out of raising more bacteria in your compost, because it'll have this effect on the protozoa. But without a microscope, you don't know if you're like at what point you're harvesting that material and applying it. You don't know if you have a lot of those predators there. So there is, I'll just kind of share a word with you if you wanted to Google this, but the idea of a quote unquote protozoan infusion uses molasses, compost, and usually like leafy greens from your garden that you go clip. And you can intentionally raise bacteria for the purpose of stimulating the predators in a contained space and then applying that to your garden. But it's really hard to know when to harvest that without some kind of microscope. But there might be people out there who have got it down to a science and could give you a recipe and tell you when, at what time to harvest a protozoan infusion.
I was using worm compost, so I wouldn't have any E. coli contamination, but I don't know what else.
Yeah.
Use as a source.
For your compost.
Yeah.
Yeah, for your teas. So yeah, vermicompost, I would just encourage you to add a little bit of that oatmeal, like an oatmeal slurry, just kind of incorporate that every, like once a month even, and that'll probably do the trick to get your fungal numbers up. Yeah. Yeah.
Because you're talking about oat flour, what are other types of flour, wheat flour, things like that?
Yeah, I haven't personally experimented with those, so that's why you won't find them listed there. But take to the internet, see what people are saying. In general, like if it's more of a whole food source, so it's not like a refined flour of some kind, it should generally favor the fungi over the bacteria. Yeah. Yes.
Yes, you can buy commercially a gallon of supposedly concentrated humic acid. What do you think of that? Is that useful, or is there something wrong with it?
Yeah, humic acids are definitely tricky in terms of differentiating the source. So one thing to keep in mind is how they're made. If they're, you want something that's like been extracted through water, as opposed to like going through any more processing. It's hard to know that though. But in general, my experience is when looking at, I've used some liquid humic acids and some powders, is to definitely dilute. All you need in your compost tea, your compost extract that you're making is enough of that humic acid to turn the color just a little brown. And that's enough to really get the job done. So you don't need much. And don't let them tell you otherwise. They're trying to sell their product,
Let's see, one other thing. Now, this is going to be totally off the wall, but you have your oatmeal or your oat flour out there. Once you bought, let's say you went and bought a yard of commercial compost, and it's finished, and it's not hot. Is there any purpose in sprinkling some oat flour or oatmeal in that? Can you change in the short term the biology of something that you have? Or for that matter, does it do any good to put it on the ground around the plants and scratch it in? Is it going to change the biology, or is that just a dumb idea?
Right. I generally, my take on, oh gosh, there's so much good there in that question. I like, okay, so I have to remember to repeat the question too. So let me capture that for the Zoom audience. The question is, when you're adding, like when you have industrial made compost, can you go ahead and add oat flour to that compost to, shift the biology to be more fungal? Or could you add oat flour right into your garden to influence the fungi to bacteria ratio right then and there? I'll tackle the first question, and I am a huge fan of just amending the industrial made compost as much as you can. So that would look like if you have just a small worm bin, but you're trying to top dress a rather large area, so you don't have enough solid compost to do that, you're going to have to go out and purchase some, and that's fine. But maybe what you can do is make an extract out of the vermicompost that you have at home, or whatever kind of compost it is, and then use a sprayer and apply that to the compost you purchased. So a little bit of solid goes a lot farther as a liquid, right? And so you can apply that to your large batch of compost you purchase. And while you're at it, go ahead and add the oat flour to that sprayer, and you're adding that as well to your compost, or you can sprinkle it on and just lightly work it in. Now, as far as like in situ, like on the soil, adding oat flour, my philosophy on this is that we mostly want the plants interacting with the biology. So I subscribe to making introductions. Hello plant, here's your microbes, like y'all have at it. And vice versa. Like if I'm introducing microbes to the soil, I want to be planting plants or seeding or something, so that we have this plant microbe interaction. And then it's my job to protect the soil. And you can do that with wood chips and straw and things that actually do feed fungi. But I don't like to really feed the soil outside of that. I prefer doing it contained in the compost, and then just making the introductions and letting them take care of each other because they're communicating. Yeah.
So I have a chicken area, and chickens are great for breaking it down.
Yeah.
And so right now I add in there straw, and plant waste, wood chips, there's a bit of logs and things like that. And I'm starting to be able to clear it out and get compost, but it took several years.
Oh, wow. Yeah.
It was, barren.
Right.
I started. I heard about this method where creative farming, where you can ferment that area. Do you know much about that, or do you have anything recommend for what else I could add to it?
Right. Yeah. So the main gist of the question is regarding K&F methods and using fermentation in a lot of these different applications. I don't know much about that. What I do know is that K&F is leveraging microbiology, just like soil food web methodology is leveraging microbiology to benefit plants. I think there's a lot of interesting things going on with K&F methodology, but it requires a lot of tailoring of the fermentation and the anaerobic conditions. And all I know is that healthy soils don't tend to have things like yeasts and the organisms that we find in fermentation. That's not to say that the byproducts of those processes can't impact our plant health. So there is a lot of signaling, for example, that I understand comes from K&F products, like a plant fermentation. You're generating plant signaling metabolites, and then you're introducing that to the plants that are in the ground, and then that can have this kind of impact. And so there's a lot of interesting things happening there, but I wouldn't say when it comes to composting that I would avoid fermenting things. Yeah.
So what else could I add to the chicken area that was there?
I can send you some articles. There's a mycologist named Travis Otter who has a system where he uses mycelium, especially oysters, to do kind of microfiltration where it absorbs the nitrogen rich compost and breaks it down.
Yeah, it's honestly, it sounds like it's probably pretty diverse, because you have the chicken waste, right? That's going to be generating a lot of like bacterial activity, but then all of the things that you're adding into that system sound to me like they're woody materials, like your straw and wood chips and things. So I would say that it's probably in pretty good shape as
You
it.
can't really add like fertilizer, you can't add that stuff, you know, your chicken makes it.
Right.
So my other question is, so it took me a while to figure out, because I have wetland prairie soil. And my soil really loves the wood chips.
Mm-hmm.
And so, but the bacteria or the fungi are coming in to eat that, is that what's going on?
Yeah.
That might sound pretty quick.
I know, same. Yeah, I also have a really clay heavy soil, and the wood chips just disappear out there. And to me, that means it's a hungry soil.
It's like
Yeah.
better.
Yeah.
Where I lived before, I didn't like that, I got a different kind of compost.
Hmm.
when I lived downtown. Now it's like the wood, I wouldn't have thought that would have been much.
Yeah. I mean, if you think of Blackland Prairie, like it was mostly grasses, like dried, dead grasses that were being incorporated into the topsoil, you know, as far as a fungal food goes, and not necessarily wood chips. But yeah, they're in general, like our soils are so deprived of these fungal foods that I find that mulching areas, it tends to really generate.
Leaves don't break down as quickly as wood does.
Oh, as the wood does.
Yeah. I've been using a lot more leaves because they're such a great material for polar vortexes.
Mm-hmm.
And so I'm just gonna get bags of leaves on the side of it.
Mhm.
Pile them up for vortexes, and so that I tend to float around the garden a lot more now.
Right.
But they just break down, which is actually fine, it keeps the moisture in the building, but
Right.
I'm surprised actually that they don't break as quickly as the wood does.
Yeah, that is interesting. Yeah, I've actually noticed that too, but for the people listening online, that the wood chips tend to break down quicker in some cases than dried leaves. Yeah, so definitely when you notice things like that, when you're making those observations, well, to me, that means I'm better off using my dried leaves in my compost so that they actually break down so I can return the nutrients that way. Yes.
Got a lot of gardening on Black Lake and greatest for like trenches
Mhm.
to make a raised berm to get the plant up
Mm,
on the floodplain.
okay.
And I filled up those trenches with branches, wood chips, bamboo,
Yeah.
a lot of woody material.
Yeah.
And of course, by the end of the season, dirt has washed in and sort of filled it. And in a few years, that seems to be very rich humus, usually a lot of worms. Is that an efficient use of all that carbon material?
I think that's a great use. So the way you described that reminds me of hugel cultures, right? And yeah, again, for those listening online, you were digging out a trench and building berms and things, then you'd fill in that space with woody materials, logs, any kind of branches and that sort of thing. Yeah, I think that's a good way to do it. The big thing with woody materials is if they're just exposed and dry, it takes a lot longer to turn any of that into a useful kind of humus. So it sounds to me like you are finding success because of that combination of the soil kind of backfilling in and commingling with the branches you laid down. Whereas if those branches were just exposed and not in contact with the soil as much, it would take a lot longer for that stuff to break down.
Plus, if and when it does rain, water fills the trenches rather than running off.
Right.
So quickly.
Right.
So
So
it's
keeping
getting
it moist. Yeah, exactly. Yeah. Moisture for sure. Yeah, Austin.
Yeah, I have a question. On a range of bacterial compost, fungal compost, we have a picture of it. And this, I guess, is my what I thought through. The fungal is more appropriate for woody plants and trees. And you mentioned brassicas down closer to
Mm-hmm.
bacterial work in general, vegetable gardens and herbs, would maybe more
Yeah. Let's go back.
more beneficial.
So like in general, like most of our food crops are kind of in the middle. So we actually want a fungi to bacteria ratio that's closer to 1 to 1. And but just assume that your fungi to bacteria ratio right now is like 0.01, 0.05,
Hard to get.
0.1. Yeah, so it's bacterial is dominant and very little fungi in most cases, and even in gardens that have been like tended to, a lot of times I'm still finding that ratio to be really low. But just by bringing a little bit more awareness to it and making these subtle changes, mulching regularly, incorporating fungal foods into the composting process can really change things in a pretty short amount of time.
Okay.
Yeah.
So you don't really have to worry about being too far.
That's true. Like if you're too far, in theory, yes. And this comes up more in ecological restoration than in gardening, or in places like turf systems. If things are getting too fungal dominant in turf, then we kind of want to disrupt that system through something like aeration is like enough to kind of knock back fungi, maybe introduce a little bit of a molasses or some simple sugars to just make sure that we're staying in that closer to 1-to-1 range, that target range, just so things don't become a thicket, or encouraging the bushes and the trees to start creeping in on certain properties. But in general, in the garden, I don't see. This is also where like the plants are kind of informing that it is in relationship. So as long as you're picking cover crops that are also in a similar succession group as your main harvested crop, that can also help keep that balance from year after year.
So there's some more questions
There's
on
more?
Zoom. If
Okay.
you want me to like pull up the chat, I can also relay them, but it might be easier for you to read them and repeat
Yeah.
that.
Austin, do you want to hit me with your question while I pull that up?
Yeah, can you speak to the cleaning nature of nitrogen?
Yeah. Hold on, let me pull this up before where'd y'all go?
There's chat. Yeah, maybe stop the share and then you'll see the menu. I think the menu went onto the other screen.
Okay, I mostly just can't find my Zoom at all. So let me pull. Oh, that's because I minimized it. Gotcha. Okay. How do I get all of you back? Is it still sharing my screens?
Share. No, I think the menu's like over on the other.
Sorry. It's over there. Oh, I see it now. Okay.
It's like kind of hidden.
Technology.
You can just kind of drag it over here.
Okay.
And
All right.
also,
So the fleeting nature of nitrogen, are you talking about like when like losing nitrogen, like leaching, like in runoff and stuff?
Or like for soil tests and stuff, like it doesn't stay in the soil very long.
Yeah. So it really comes to the nitrogen cycle, right? We want nitrogen to be cycling, which means a lot of nitrogen is quote unquote tied up in the soil life, and not accessible to plants. But that's a good thing because that kind of means it's just being stored in a long-term way in the bodies of these organisms. And as one eats the other, it consumes what nitrogen it needs, and then it kind of spits out the rest it doesn't need. And so nitrogen is just always kind of flowing as long as the soil food web is functioning. What's happening in these bacterial dominant soils is that there's not a lot of predators eating the prey. And the explanation for that is like, well, if they have so much food, if they have such a big food resource, why aren't the predators there to feed on this bacteria? And what it boils down to, for me, is generally a lack of habitat in the soil. Like there's very little aggregation. Like these microbes need aggregates to live inside as their habitat, and to maintain the moisture when things get really dry, so that they have the reserves to sustain themselves. But when we don't have a lot of organic matter, we tend to lose habitat for those more complex organisms, and only bacteria can survive. So yeah, nitrogen in plant available form is water soluble. That's how the plant uptakes it. That also means when we apply fertilizers that are water soluble by design, so the plant can take them up, whatever the plant doesn't take up, it runs off. And so having nitrogen in more of a biological form is actually a more resilient source of nitrogen. Yeah.
Lots of food left.
Okay, yeah, come get a plate. All right, I'm gonna look at these questions on here. So we talked about slime molds. How about garden soil purchased that has zoo manure mixed in it? Ooh, you got some exotic manure. Yeah, I just want to know if if the source of the manure was actually properly composted. Manure, again, is a bacterial food primarily. So what else was in that garden soil? These are the kinds of questions to be asking. Does pine straw feed fungi just like the straw and wood chips you mentioned? Things like pine and cedar have antimicrobial properties. Like if you can smell it, right? Those are the volatile organic compounds that a tree made to defend itself from microbes. And so they will suppress microbes in a compost. The best way to deal with that is to I like to heap these things up. I'll water them, I'll lightly feed them fungal foods actually. So whether that's a bunch of pine needles, a bunch of leaves, a bunch of wood chips that I know have a lot of cedar in them, I'll lightly feed those with the fungal foods. And I just every now and then come by and I take a handful and I smell it. And the day that I can no longer really trace that pine smell or that cedar smell is the day I know like I can start composting with this pretty successfully. It's not that you can't compost cedar, it's just that it'll be a lot easier for you to, it won't hang around as long as, you mentioned struggling with if you allow it to age a bit. What's your favorite mulch to use directly in the vegetable gardens? Aged mulch of any kind. So that can be, I guess I have a tendency to use aged wood mulch. But you could use other materials. Straw is good, but I like the aged stuff because it's more biologically active. When it comes to adding mushroom blocks to compost, are all mushroom types relatively equal when it comes to amending soil, or are there some we should prefer over others? Mushroom blocks. Okay, so the mushroom blocks specifically, I would say what's really happening is that a lot of the species don't really survive through the composting process. So it's not like, once you compost the blue oyster mushroom block in your compost and then you distribute that onto the soil. In general, there's probably not going to be a lot of blue oyster that survives the trip through the composting process and would start popping up in your garden. But all of the materials that were in the substrate, including the mycelium itself, fed other species of fungi. So some people have concerns about using too much of the substrate, the mushroom substrate, because you're kind of inoculating your soils with, you're perhaps raising a compost that only has like 1 or 2 species of fungi. I have that concern, but again, going back to that 30% or less component, like 30% of the volume of any one compost being these mushroom blocks, as opposed to like 100%. I think in general, like you're fine. You'll end up with a diverse set of organisms and you won't have to worry about it becoming dominated by any one of these culinary mushrooms. I do think maybe some of them are considered quote unquote better saprophytes than others, but yeah, I hope that kind of answered your question. I don't think of any of them being better than.
And like, we had one speaker who was at Texas A&M, and she worked with USDA on looking at what fungus in our region was the most aggressive, and turkey tail was the most aggressive and fastest decomposer.
Cool. Okay.
They're usually not grown
At the culinary mushrooms.
Yeah.
Okay.
Yeah,
All right.
it's a medicinal, so. But if you can't get your hands on spawn and you're into growing medicinal mushrooms, that one's the fastest.
Okay, that's good to hear. So yeah, turkey tail is what Angel says is the most aggressive eater. Is there any particular fungal species or phylum that are most impactful in the soil? So a similar question. I don't get too hung up on obsessing over specific species. I get hung up on obsessing over diversity, right? Like I want to see more diversity than anything else. So I'm not trying to hone in on the best fungal saprophyte or mycorrhizal fungi. It takes all of them to make a really healthy soil. So what I'm looking for in the soil samples is there a diversity of different fungi here? All right, I think that was it.
And do you have some maybe I love seeing your videos you share on Instagram of like what are
organisms,
nice, diverse, or what fungi looks like under the microscope, or how you see
okay, I actually had some hidden slides here. I'll just unhide them and we'll show you some microbes. I'll share my screen again in here in just a second. Share screen. Share this one. Open share screen too. So look and see. So this is what fungi looks like on the microscope. The one in the top left corner is a total magnification of 100x. So that's actually like zoomed out quite a bit. We do most of our observations at 400 times magnification. So that's a very thick piece of fungal hypha. So if you're familiar with the term mycelium is a bunch of fungal hyphae put together. I kind of think of it as like a bunch of cables in a conduit. The conduit is the mycelium. The cables are the hypha or the hyphae. And what you're looking at there is a single hypha, is that one strand. And so in general, the wider the diameter, the darker the color, like the more mature the fungi is, the more beneficial it is, the more carbon it's storing, the more it's exuding enzymes into the root zone and generating more plant available nutrients. So, as far as getting picky about what kinds of fungi we want to see, it's not any one specific species, like I mentioned before, but we do want to see wide diameter, dark colored fungi in general. So this down here is kind of, when we're looking at a drop of water, there's a depth to it. So as you watch this video, I'm kind of focusing in and out of the depth of that, and that's a fungal hypha strand there. And it looks just like they depicted it in the textbooks. It has the septate wall, it has this strong outer cell wall. I think there's also a flagellate that zooms around in the top of that video right there. That's a tiny little flagellate. It's feeding on bacteria as it's moving around. And all those little vibrating specks, the round dots, those are bacteria. So some of the more charismatic characters in the soil. This is a really unique flagellate. that changes shape. So you can actually see the flagellum on this one whipping around to move itself. And it starts out kind of looking like this mushroom cap shape. And then as the video goes on, it elongates itself. But this is an example of a bacteria predator. So as this flagellate feeds on bacteria, it takes the carbon and nitrogen it needs from that bacterium, and then its waste product. I mean, if flagellate poop, then it's pooping out the nitrogen it doesn't need, basically. And that becomes plant available nutrients.
Is that real time?
Yeah, this one's real time. Yeah, so that one's actually moving slower than most. Yeah. So that was kind of a fun one to capture. Let's see, what else do we have here? Okay, so amoeba, like usually when we think of an amoeba, think of like a blob, right? I love a good blob. I have an example of a blobby amoeba. We call that a naked amoeba because the other type of amoeba come in what we call a test. And so that's what an example of this one. This kind of oval shape in the center there is kind of like this shell that the amoeba is protected inside of. And so when we look at a drop of a soil sample on the microscope, in order to do that, we have to shake a test tube of water and soil. And usually the amoeba like grab a piece of organic matter and bring it in their little test state and hide. And so we don't see them very often preying on bacteria like we would the flagellates that are just kind of out and about shamelessly preying on bacteria. But this is a very unique situation where I found, I'll play this video for you, let's see. Where we found a testate amoeba, hopefully this plays for you. Preying on bacteria. Let's just give it a second. It says not available, quick time not available. Well, I did a lot of building up for that one for it not to work out. There's a lot of this on my Instagram too, at soil is sexy, if you're interested. I'll see if I can get a different one to play. This one's the naked amoeba. This is also real time. So that naked amoeba, you see that like circle inside of it, that's a vacuole. And so that's what's collecting the waste, like all the nutrients that it doesn't need. And then it'll flush that vacuole and release those nutrients into the soil. Again, those are water soluble nutrients when it does that. So you can actually see the bacteria kind of congregating inside that organism, which is pretty cool. All this other stuff is like organic matter, mineral matter. So this one's kind of cool. This is a nematode inside of an egg. So it hasn't hatched yet, but it's moving around if you look really closely on the inside. And so, yeah, when I went to A&M and studied ag and life sciences, the only nematodes they chose to tell us about were the kinds that feed on roots. And so nematodes bad, nematodes feed on roots. But there's actually so many other kinds of nematodes that feed on bacteria, that feed on fungi, and they're cycling nutrients when they do that. They also feed on each other. There's some predatory nematodes. This is an example of one feeding on bacteria. So if you look at the top of that organism, towards the top of the slide there, it's moving its lips around, slurping up bacteria. And it has a valve kind of in the center of it that's pumping as it's digesting this. I think that might be my last one. So kind of my highlight reel that I had on standby, but I generally share little micro videos on my Instagram and newsletter as well.
Thank you.